Welcome to Algebra 2, section 7.4 in Big Ideas, which is adding and subtracting rational expressions. So this section immediately follows multiplying and dividing rational expressions, so you are well used to factoring each piece. But adding and subtracting rational expressions is going to come with the extra component that in order to add or subtract fractions, we're going to need a common denominator. So here are some steps to use as a general guide to follow. The first step would be to factor each piece, specifically in the denominator. And then we need to make a common denominator. So the way that I phrase this is that we would multiply by the missing factor needed in order to make a common denominator, which you'll see as we do some examples. Then once we have a common denominator, we can actually add or subtract, write it all as one fraction, distribute combined like terms on top, and then if possible, refactor to see if anything will simplify. We're going to start out with some easier problems, some middle school type problems, so that you can see the types of problems that you'll encounter with the more difficult expressions. In the first example here, 3/5 plus 9/5, the denominator is already a common denominator, so I'm just going to add across the top to get 12/5, and then if that simplified, I would simplify it, and it doesn't, so I'm just done. In example 2 here, the 3 and the 9 are not a common denominator, but 9 is a multiple of 3, so I would notice that the least common denominator is 9, and I would multiply this first fraction by 1 in the form of 3 over 3, creating 12/9 plus 2/9, which then would add to 14/9. So I had to multiply one of the fractions by something, but not the other one, in order to get a common denominator. In the third example, 7 and 6 are not the same denominator, and also they share no like factors at all. So I would actually need to find the least common multiple of 7 and 6. I could do that by writing out multiples of 7 and multiples of 6. You may have been taught that in middle school. 7, 14, 21, 28, etc. And then doing the same thing with 6, 12, 18, 24, etc. And eventually you'll get to 42. You're looking for the smallest one that they share. The goal would be that you would be able to come up with the fact that the least common denominator would be 42 in this case without needing to write the multiples. Once you've come up with the fact that the least common denominator is 42, that means I would need to multiply the 7 by 6. So I'll multiply the numerator and denominator there, and I'll multiply the 6 by 7, so in the form of 7 over 7, so that I don't change the value of the expression. And that would be 6 40-seconds plus 35 40-seconds, and then now that I have a common denominator, I would add and get 41 over 42. In the last example, the 8 and the 6 both share a common factor of 2, but 8 is not a multiple of 6. So we can figure out what the common denominator is. This one is the most like what we're going to be seeing in Algebra 2. We can figure out what the common denominator is by breaking these into prime factorizations. So 8 would be 2 times 2 times 2, and 6 would be 3 times 2. And then I need a denominator that will cover the 8 and cover the 6. In other words, for the 8, I'm going to need 2, 2, and 2. But then to cover the 6, I've already got the 2 there, so I would just need the 3. And now if you notice, I can see that the 6 is covered in the common denominator, as well as the 8 is covered in the common denominator. It's okay that they overlap as long as each one individually is covered. If I multiply those together then, 2 times 2 times 2 times 3, I would get 24. So 24 would be the least common denominator in this case. Notice that the 8 has the 2 times 2 times 2, so it needs the 3 in order to make a common denominator. So I'll multiply this one by 3 over 3. And then the 6 has the 3 and the 2, but it's lacking these other two 2's up here. So I would need to multiply it by 4, right? I would need a 2 and another 2, which is equivalent to 4. So I'd multiply by 4 over 4 to make a common denominator there, and then that would provide me with 9 24ths plus 4 24ths, which is 13 24ths. It is worth noting that if you don't find the least common denominator, maybe we would have multiplied the 6 and the 8 together and gotten a common denominator of 48. That will actually work and provide you with the right answer as long as you're following the correct mathematical steps, but you'll need to reduce that then at the end. So it provides extra work later if you don't find the least common denominator. With those things in mind, let's go ahead and move on and look at a few Algebra 2 problems that are adding or subtracting. In the first one, I've got x plus 1 over x minus 1 plus negative 2 over x squared minus x. I need to factor anything that is factorable. So the denominator of that second fraction, I'm going to need to factor. Turning this into x plus 1 over x minus 1 plus negative 2 over x times x minus 1. So in thinking about the least common denominator, I certainly need a factor of x minus 1 in order to cover the first fraction. And then for the second fraction, notice then I've already got the factor of x minus 1. I would just also need a factor of x. So the second fraction does not need to be multiplied by anything, but the first fraction would need to be multiplied by x in order to create a common denominator. If I multiply the bottom by x, I've got to multiply the numerator by x as well, because otherwise I'm changing the value of one of those expressions. So now that I have a common denominator of x times x minus 1, I can go ahead and distribute across the top and then add. So this becomes x squared plus x minus 2 on top over x times x minus 1. Then the directions said, if possible, refactor the numerator now that I've combined my terms so that I can see if anything else may cancel out again. Turns out for us that the numerator does factor into x plus 2 times x minus 1. And so when I look at that, which we are required to re-simplify if that's a possibility, when I look at that, then I can see that this would create a hole in the function with the like factor of x minus 1 on the top and bottom. So I would cross that off. My final answer would be that this equals x plus 2 over x. At this point, you cannot cross out the x over x because the x plus 2 is glued together by the plus sign. It is all one factor. Please remember that you cannot cross out anything that has a plus or minus sign next to it. We can only cross out entire factors, like I did here, that this has a times dot next to it, and so does this, has a times multiplication symbol next to it. So I can cross out entire factors, but nothing, no terms. If I want to look then at my answer and discuss my excluded values, which would be what can x not equal in this problem, I don't want to look just at my final answer. I want to look at the components of the individual pieces. So I'm going to go back to the original problem and look and say, well, what makes either one of these denominators equal 0? Turns out if x equals 0, then that does not work. But also if x equals 1, that does not work either. So those would be the excluded values that would go with our solution. Moving on to a second example. in this example, the first denominator is x squared, and the second is x squared plus 2x. It may be logical for you to think, oh, well, I'll just add 2x over 2x to the first fraction. But adding is not on the list of things that are allowed to do. That changes the value of the fraction. Just as an example to think about, if I took 1/2 and I said that I was allowed to add the same number to the top and the bottom, like +1 and +1 here, and that shouldn't change it, well, then that would mean that 1/2 is equivalent to 2/3, and that's clearly not true. So we cannot just add something to the top and bottom. It has to be multiplied, which is why our keyword of the day is going to come back in, which is factor. So we're going to factor that second fraction there. This becomes 3 over x squared minus 5 over x times x plus 2. So I'm going to start creating my least common denominator, and I'm just going to grab all of the factors of anything that I would need to make sure that both of the denominators are covered by my least common denominator. So I certainly need at least x squared to cover the first fraction. But then the second term, I need an x and an x plus 2. I already have an x because x squared is x times x. So I've already got that. But I will need the factor of x plus 2 as well. If you want to write this as x times x plus 2, so that you can see that the first denominator fits inside and also that the second denominator fits inside, you would be welcome to do that, but it's unnecessary. So if that's the least common denominator, I need to see, well, what should I multiply each fraction by in order to get that least common denominator? The first fraction would need multiplied by x plus 2 over x plus 2. Remember, we're always multiplying by 1 in the form of something over itself, so that we're not changing the value of the expression. The second fraction has x and x plus 2. It just needs another x so that I can get that x squared there. So I'm going to multiply the second fraction by x over x. Then I can go ahead and distribute on the top and start combining like terms. I can combine these into one fraction. So x squared times x plus 2 is my denominator. And then let's look and see what I have on top. I'll have 3x plus 6 minus 5x on top. And so when I simplify that, that becomes negative 2x plus 6 over x squared times x plus 2. So with this problem, we're done. The last step that I mentioned about you should refactor to see if you can simplify. If you can do that in your head, you might notice that I could take out a negative 2 here, and then I would be left with x minus 3 on top, and I would have the x squared times x plus 2 on the bottom. Factored versus expanded, one is not more simple than the other. They simply have different uses. So either one of these expressions would be sufficient for the correct answer. The factored form is helpful if we think that something is going to end up canceling out on the top and bottom and reducing. But if you can tell from noticing with the negative 2x plus 6 that nothing is going to cancel out, then it's not super necessary that you go ahead and factor it out. If you're not sure, then factor it out to see if something might cancel. Looking at the excluded values here, we're going to look at the original problem and say what values of x would be disallowed here. And I can see that if x equals 0, then that would make the first fraction 0. So x cannot equal 0. Sorry about that. And then if x equals 0 or negative 2, then that would make the second denominator equal 0. So the disallowed values would be x cannot equal 0 or x cannot equal negative 2 either. Moving along to our third example. Again, I want to factor each piece that is unfactored. In this case, I'm not going to rewrite the entire thing. I'm going to notice that x squared minus 4 will factor into x plus 2 times x minus 2. So I'm just going to cross that out and write that right underneath it to save myself some work. And I can notice that the least common denominator, I'm certainly going to need a factor of the x minus 2 and the x plus 2 so that the second term will fit in. But once I have those, I actually don't need anything else because the first fraction is covered with the x minus 2, and then the second fraction is covered with the whole thing. So I just need to multiply the first fraction by x plus 2 over x plus 2. When I do that, I'll have x plus 2 times x minus 2 on the bottom. And on top, let's see what I would get. I would have 1x plus 2, distributing, although it's a 1, so there's nothing to distribute. Here, be careful on this subtraction problem that we're subtracting the entirety of the 3x plus 1. So the fraction bar functions as parentheses for the numerator and denominator, and I need to think about that as minus quantity, 3x plus 1. So when I'm combining like terms and distributing, the negative gets distributed to the 3x as well as the 1. I'm subtracting all of 3x plus 1, which means I'm subtracting 3x and 1. Combining like terms, I get negative 2x plus 1 over x plus 2 times x minus 2. The disallowed values here would just be x cannot equal 2 or negative 2, because in the original problem that would create dividing by 0, which is not allowed. Nothing cancels out here. There is no factor that is the same on the top and the bottom here. Just a couple more left. In this one, I have quadratics in the denominator of both terms, so they both will need factored, and then I need to see what my least common denominator will be. The first fraction would factor into, would factor into x minus 2 times x plus 1, and the second one would factor into x minus 2 times x minus 1. So if I'm looking for my least common denominator, I know that I would need at least a factor of x minus 2 and a factor of x plus 1 just to cover the first fraction. Then if I look at the second denominator, I need x minus 2 and x minus 1. I have the x minus 2, but I would need the factor of x minus 1 so that the x minus 2 and x minus 1 collectively will make the second fraction covered. That means I'm going to have to multiply both terms by something, right? Neither one is okay without being multiplied by anything. The first fraction would need to be multiplied by x minus 1 over x minus 1. And the second one then has the x minus 2 and x minus 1, but is lacking the x plus 1. So it needs to be multiplied by x plus 1 over x plus 1. At this point, I'll have x minus 1, x plus 1, and x minus 2 in the denominator. It does not matter the order that you want to write those factors since multiplication is commutative. And then let's go ahead and distribute and simplify across the top. From the first term, I would have 2x squared minus 2x. Then again, remember that we are distributing the negative to the entire second term because we're subtracting that entire term. So that would be the same as thinking about that as minus 4x times quantity x plus 1, which would turn into minus 4x squared minus 4x. Combining like terms across the top, I would have 2x squared minus 4x squared is negative 2x squared. And then negative 2x minus 4x would be negative 6x over x minus 1 times x plus 1 times x minus 2. And then again, You should, if you're not sure, if you think that something may simplify and cross out and reduce, then you should refactor the top. So I can see that the top has a greatest common factor of negative 2x. And if I take that out, I would be left with x plus 3 on top over x minus 1 times x plus 1 times x minus 2. So it turns out that nothing actually cancels out from the top and from the numerator and denominator at the same time, but it was worth checking just to make sure that nothing actually canceled out. And either form here, either form is the correct answer. It's just a matter of factored versus expanded. The disallowed values here would be anything that makes the denominator equal 0. So x cannot equal 1, negative 1, or 2. Here are the last two problems that we're going to look at. These are called compound fractions, which means it's a fraction inside of another fraction. In fact, the second example has multiple fractions inside of the fraction. With these, you need to be careful that you think about the size of the fraction bar and which one is being divided by which one, because it matters. Just as a quick example, if I have 100 divided by 50 divided by 2, or if I compare that to 100 divided by 50 divided by 2, these are not equivalent expressions, even though if I'm not paying attention to the size of the division bar or the fraction bar, they could look equivalent. In the first one, this would be 2 divided by 2, which is equal to 1. But the second one becomes 100 divided by 25, which is equivalent to 4. So just a word of warning on that when we do have compound fractions, to make sure that you're being careful about how you're writing it and make sure that your writing is nice and organized. The goal for the compound fractions would be, if I can create a common denominator for the numerator and a common denominator for the denominator, I can turn the fraction bar into a horizontal division bar. So I'm going to consider this two little mini problems. The first one as 1 plus x over y, and then the second one is just 5x, which there's nothing to do there. And then I would be dividing those. If I make a common denominator, if I just consider this fraction of 1 plus x over y, and don't even look at the rest of it, the common denominator there would be y. So I would take the 1 and I would multiply that by y to make y over y plus x over y divided by 5x. And that would be y plus x divided by y divided by 5x. Then we can either turn that into a horizontal division symbol and think about multiplying by the reciprocal of the second fraction, or we can think about, if we're dividing by something and then dividing by something else, that would be equivalent to dividing by both of those expressions. So both the y and the 5x are going to end up on the bottom. It's up to you. I'm going to go ahead and just change this to a horizontal division problem. This would become y plus x divided by y divided by 5x over 1, which would equal y plus x over y times 1 over 5x, which would equal y plus x, but I'm going to write x plus y to have it nice and neat in alphabetical order, over, then the bottom would be 5 times x times y. And that would be my answer that I have created, done a couple little mini problems, and then created common denominators for those. So I'm going to move those over to give us a little bit more room on the next problem. If I look at the disallowed values, or the excluded values in this first problem, Anything that is going to create division by 0 is an excluded value. So the y here cannot equal 0. Also, the x cannot equal 0 because that would mean I'm dividing by 0. And other than that, looks pretty good. Those would be the only disallowed values for that problem. Now let's look at the other problem, which is similar for sure, but has two fractions inside the larger fraction. I want to apply the same process. So I'm going to think of the first one as its own little mini problem and the second one as its own little mini problem. And then I can simplify by writing it as a horizontal division. In the first one, the y would be the common denominator. So this would become, if I make 1 in the form of y over y, then this becomes y plus x over y, as you saw in the last example. The bottom part of this problem, the denominator here, would have a common denominator between x and 1. That common denominator would be x. So I would need to multiply by x over x for my second term on the denominator, and that would give me 5 minus 3x divided by x. Then, once I have one fraction on the top divided by one fraction on the bottom, now I can rewrite it as horizontal division, that this would be y plus x over y divided by 5 minus 3x over x, which is equivalent to y plus x over y times the reciprocal, x over 5 minus 3x. Then when I multiply, the fraction bar, because it functions as parentheses, when I multiply and put this together, I will want to put parentheses around those, and I'll get x times x plus y divided by y times 5 minus 3x. For the disallowed or the excluded values here, we need to go back and see what would make any value, anything in x or y that would be creating division by 0. So the y from this original problem cannot equal 0. The x also, because in the original problem I've got 5 divided by x, so x can also not equal 0. And then, because this is division, once I created this common denominator, in this case, if 5 minus 3x equals 0, then that's like saying I've got this fraction divided by 0. So 5 minus 3x cannot equal 0 either, which means x cannot equal 5/3. So those would be the disallowed values, that if x equals any one of those things or y equals 0, then that would create division by 0, which is not legal. I hope this helps in your quest to understand adding and subtracting rational expressions. So good luck and have fun.